Okay, so we're gonna do this one, guys. So basically, you guys are given a template, right? So so let me open the code. So I'm gonna put this one in. Sorry, in here, guys. Okay. All right. So you are given this template. Okay. And or you are asked to actually copy this code to your own Colab. Okay, you can do so over here as well, like clicking on file and then save a copy in Drive. You can do that as well, or you can simply copy this code and then create your own Colab and paste it here. So that's what I'm going to do over here. Okay, so I'm going to get a new cell. Okay, so right here and then paste it. Okay, so this is the template. Okay, few things. Okay, um, and then if you have any plans to, like, use this kind of plotting in the future using Python, I highly recommend keeping this template and then using reusing this code, because pretty much this code gonna give you like a versatile set of plots, right? So and then they are complex plots, and pretty much in a real world analysis you're going to have more than one plots together, right? So this is going to basically put three horizontally as well as three vertically as well as all three in a single plot as well. Okay, so and you can use reuse that code and in future plotting incidences as well. Okay, all right, so few things to note. Okay, so you can see over here matplotlib is the main module, right? So and you can see that it's a huge library, right? It has sub module called pyplot, right? And that's the only one that we need, so that's why we are actually importing that only one. Okay, so 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 remember we talk about dot notation to access attributes, right? So this sub this pyplot is actually a sub module or like internal library inside this big library. So it's also an attribute, right? So we access that using dot notation. Okay, and then what we did was we used the as keyword to shorten a name, right? So that basically you can see that several location we're gonna use the same name, this whole big name. So kind of inconvenience having to type it or even copy paste that, right? So why not giving a shorter name but still it making sense, right? PLT means plot, right? So it's a shorter name but it's still making sense. So to shorten that name you can use the as keyword and like this. Okay, all right, so that's remember you can do that always. Okay, all right, so I wanted you guys to read this code properly and understand the names given, right? So the first function, right, I kept the number of rows 1 and then columns 2, right? So you can see that in the plot I get single row, right? So see the title is CA population, right? And two columns 1 and 2, right? Single row. In the second function, right, I kept the number of rows to 2 and kept the columns to 1, right? And then you can see that I put the title over here, right? So oh sorry, over here. So that's the second plot right here. Single column, 2 rows, row 1, row 2. Okay, all right. So then my question was for you guys was to add these, right? So add the meaningful title to the plot, right? To the big title, right? And then add I think another plot to the right of second plot, right? That means make the columns to 3, right? And also change the the tick mark to blue star. Okay, and then add meaningful titles to x and y axes, and then make all three in a single column as well. Like meaning basically convert them to, like, plot them separately vertically. Okay, so this one is the second function and this one is the first function. Okay, so let's do that. So right, so what do I have to, so basically in this one, right, so what should be the number of columns then? 3, right? So we are changing from 2 to 3. Okay, so that means this is the plot number 1, plot number 2. You can simply, copy this code and change. Okay, so the plot number 3. Okay, so what should be the x-axis then? X-axis is going to be same, right, here for all of them, right? And you can see down below they are coming in as lists. Okay, so that's why kind of we learned list earlier. Okay, all right, so the year is coming as a list and that's actually the x-axis. And then for here, right, I think, let me see, over here for the plot 3, this should be, this should be density rank, right? Density rank, right? So I'm gonna copy that. You can have a different name as well, but let's use the same name. So density rank. So I'm going to use the density rank. So right here, and it should be blue star. So I'm going to change this to star. Okay, all right, all right. So we can now check this out. So this need to be coming in as a parameter to our function as well, right? So I'm going to pass them as a parameter. Okay, all right. So density rank. So also they should be in the call as well. So I'm gonna put that parameter as well. Okay. All right. So let's run it. And you can see that density rank is now on the third column. Okay. All right. So we changed the column number to 3 and added that plot. Okay. So right here. Okay. So how do we add? How do we add the axis title? So let's add them to right here. So it's plot dot x label, right? So I think it's x label, right? And then we put the label, so it should be year, right? Right. Let's check this out. It should be appearing in plot 3 if we rerun it. See that year, right? So similarly, you can add that y label as well. So let's add that as well. Okay. So should gonna be here and y label, and for this one it should be what, density rank. So density rank. Okay, so if you run it, you can see that we have the y label as well. So I'll add the rest of the two sets of labels later, guys. Okay, all right. So okay, how do we add a title? I think we still need to add a title, right? So we still need to add a title to each graph, on top of each graph, right? How do we do that? Yes. Dot subtitle. Okay, so let's add that. So to the this one, plt subtitle. Yeah, that's for the entire graph. SUP title, this one is for the entire graph. Yeah, see that it's right here. SUP title is for the entire graph. For each graph, I think it's probably title. Let's try this title and then put a title like um, let's say um, density rank versus year. Let's try. Okay. Yeah, right here. And as you can see that it's still cramp up. You can also, like, there are a whole sort of ways to adjust this spacing and everything. So you can clearly get, so this is a little bit cramped. I think it's probably because of my I think um, probably because it's actually yeah, probably this tide layout making it. So try removing that and you might get a little bit different graph as well. Okay. Anyway, so you can see that at the end we have to do the plot.show. This is actually what actually printing to the screen. So show method. Okay. All right. So that second function, and you can see that there are multiple rows and single column. So we're gonna increase this number of rows to 3, right? 3, and then add that plot down here. Okay. All right. So and then for that also it's density rank, right? So density rank. So I'm gonna print copy both. Um, it's density rank, and again a blue star. Okay. So and then density rank need to be actually as a parameter. And then in the call also need to have it. All right. So let's run now. So we have now 3 rows, right? Okay. Okay. And by the way, when I post my code, guys, so you have already accessed via this one, but I'll change all of these. Like I'll put follow this way to all of these graphs, and we'll put this title to all 3, and repeat the same for all of these plot as well. And then in the final one, right? I think for the improvement, I asked you guys to plot everything in a single one, right? So I'll add that one as well later. Okay. All right. Okay. So one other thing I want to highlight. Okay. So here you can see that you are getting data as list literals, right? But when you actually seriously want to do a data analysis in Python, let's say in real world, you'll probably learn a different module called NumPy. Okay. So lists are okay, like small lists like this in Python, but when you have really large data sets, lists are really inefficient. Okay. So Python's actually answer to that one is NumPy, basically module, and then data frame as the NumPy data frame as um, like as a solution to list, right? List problem. So you will use one of them instead of list at that in basically in reality. Okay. But we are not learning NumPy in this class, so I use actually list. Okay. All right. Okay. So focus on this graph when in our what we are learning in the data module. So we are going to go back to data module. What can we see in the last graph from the last plot? And because of that, there's a consequences. I asked the same question from the previous class. I got the answer though. What's the consequences? Yes. Density rank. So that basically it see that it's clearly went down, right, for California. That means there are other states gotten more population in a higher rate than California. You can see that California population, it didn't go down, the rate got decreased compared to other states, right? So what was the consequences? It's also political as well because of that. So the rank went down, right? So that this is to indicate basically uh, other rate population gotten larger or increased in a higher rate than California. Well, entire country, population increases. There's a positive rate for the entire country, California too, right? But California rate is gotten slower compared to other states. So rank went down. So as a result, anyone? There was a really big political consequence actually happened to World Democratic Party actually, because California is a blue state, right? Like mainly Democrats. Yes, it's related. So I mean, the way we figure out congressional districts, it's based on population, right? So what happened to Californians? Two. We lost two, right? I think I think we lost two. I'm not sure the number. At least we lost one, definitely. And then Texas got one, right? So California is a blue state. So let's say lost. Let's say they lost a blue state, and then Texas is a red state, right? So they got one more red seat. So, so that's what happened. So this, I mean, this graph clearly indicates what happened to that actually. So, and I wanted to highlight that. Okay, so the advantage of plotting to see that trend, right? So, um, yeah, I think New York did. New York also lost one. No, I'm not sure though. Yeah. So yeah, so that's what happened. Okay. All right. So so let's continue, guys. So we're gonna start our string lesson. Sorry, string basics. All right. Remember, we skipped this part, right? So let's learn about strings. Okay. What is a literal? We learn about literals already. What do we call a literal? Mm, specific data value, right? It's a literal. Like for example, if you take like this Mary, it's a specific data value, right? So it's a string literal. So more specifically, this is a string literal. A literal is called like a specific data piece or data value, right? It can be an integer, so we call it integer literal. Likewise, right? So in our code earlier, right, in here, right, this actually not here, not this, like right here, right? This is what is this? A list literal, right? So likewise, okay. All right. So let's so um, a literal value like that we call a string literal, okay. And strings also a sequence type data structure. So it's container only containing characters, right? So since it can only contain character, we call strings homogeneous data structure. So only one type of things can be included, which is text itself, like characters. Okay. So unlike that, lists are heterogeneous because list can have any type of objects inside in a single list, or it can have a variety of objects types inside a single list. Okay. So for that reason, we call them heterogeneous data structure or containers. Okay. But both list and strings are sequence type because they are ordered, right? So more specifically, they are ordered sequences. Okay. So so the indexing is similar to what we discussed with the list, right? So so we can actually create a string and then access that. So I'm going to create py equals Python. Okay. All right. And to access big P given Python, I can print, right, py and then 0, right, the index. Okay. And to access the last letter n, right, given Python, I'm going to use py and phi, right. Okay. So I got that. Remember, so this is basically positive, using positive indexing, right? So positive indexing, we learn that works from right to left, right, on the sequence. So we can also use the negative indexing, right? So that works left to sorry right to left, right? So so this would be negative sorry negative 6, and this should be negative 1. We'll get the same result, right? Oops, I think I made a mistake. Okay, negative 1. Okay, so I got the same result. Okay. All right. So my question is this. So imagine this is a really large string, right? And or, you know, I can always get the last letter using this way, right? My question is there any way that we can stick to the positive indexing and then get the access the last letter, given py is let's say a paragraph? Yes. Yeah, we can use the length function, right? And then do the same, right? So for example, so we can still use the positive indexing, and then now we're going to use over here instead of this phi, because now the string is really large, like a paragraph. We don't have to count, right? You know, use length function, and then phi, put py, but it has to be one less, yeah, -1. Why? Zero, because since we start indexing 0, and then the final index will be 1 less than the length, right? Okay. So get the same. Okay. So you don't have to rely on negative indexing. Sometimes in interviews they ask something like this, right? So and then this should be the answer. Okay. All right. All right. So let's go here. That's what we discuss right now, the length. Okay. So we talk about indexing as well. All right. So so let's talk about this thing. Okay, so the changing the string. Okay, so I'm gonna go over here. Okay, and I'm going to do this side by side for both list and strings. Okay, so so what I'm going to do is I'm going to use a list. Okay, let's keep the one that we were using, this one. Okay, so I'm going to use um, I'm going to change the see, remember, right? So we can since this is a container or sequence, I have access to the whole group as a single entity, as well as we are indexing to individual indices like this as well, right? So let's say I'm going to access the 0th one and I'm going to change it to -1. Okay, all right, and then we're going to basically print it to verify. Okay, so um, okay, so you can see that it's now got changed to -1, right? Okay, so this is possible. All right, and it's basically a proof of what? This is proof of what? Strings are, sorry, lists are mutable, right? So basically once created, you can change individual element. Okay, so if you want to prove that, you can actually prove like print like it's the same entity. You're going to use, actually you're going to print the id of it. Okay, id of a list. Okay, so the address, and we're going to print it again. Okay, and you will see the same, you will see it's actually the same. Okay, so I'm going to print the id along with the list as well, or maybe different. Okay, so this is basically the proof. Okay, see that ids are same, so it's the same list. Okay, but I change the first element. So, and proof of mutability, right? So then what is the meaning of mutability? Yeah, so basically the ability to change is called immutability, right? We in practice also we sometimes call, right, mutation, right, in genetics, right? So it's basically the ability to change. Okay, so and it's a proof of mutability, right? The same list, we change the content inside. Okay, all right, so let's try to do the same for a string. Okay, so we're gonna do the same for this string as well. Okay, so right, so I'm going to change pi, um, and then let's say 0. Okay, so I'm going to change this to j. So well, I'm expecting it will become Jython. What is Jython? There's actual thing called Jython. It's Java based Python, basically Python written in Java. Yeah, so Python is kind of a coding standard. So you can pick any language and implement it using that. So right now that the regular Python pretty much everyone use is C Python, or we sometimes call Python. C is written in C language, which is really runs fast. So it's actually good to use that. But you can there's a version flavor, we call it flavor of Python called Jython, written in Java actually. There's a one written in actually I think that's called Iron Python. So that's actually C hash, I think. The Microsoft, what do we call that? The I think there's a name actually for that. I forgot the yeah, C hash, written in C hash. It's similar to Java actually, right? So it's called Iron Python. All right, so let's try to do that, and if we try to do this, it's not possible. You see that we got the error, type error. String object does not support item assignment. So this process is called item assignment because the zeroth index is an item, right? So we are assigning a new value to the that item. So this action is called item assignment. So string object does not support item assignment because strings are immutable. Okay, so not possible because strings are immutable. So it's as designed by Python designers. Okay, and then there are some good reasons for that. Okay, so we're going to learn shortly actually. All right. So this process is not possible, but this is possible, right? For both actually, you can actually create um, for example, you can create py like this Jython. Is this possible? Yeah, but this is not a proof of immutability. What do we call this then? Reassignment. So this is just reassignment. Not this is not item assignment, right? This is just reassignment. And then in reassignment, you may get even the identity change as well. So let's print that one as well. So here you can print you can see that we're gonna basically print the ID, print the ID of this py, and then if you print the ID of this, ID of py, right? And if you print the same again after this after reassignment, we'll get 2 actually. Oh, I think I need to block this, right? I'm gonna actually use it over here. I'm gonna cut it and then do it in a different. Okay, so this is reassignment. It's possible, and you can see that this one there's a big difference, right? So okay, yep. Oh, it's actually over here. Yeah, yeah, yeah. So in Colab, yeah, it's actually across cells. It works. Yeah. So this is the assignment right here, py, and that address is this. Uh, the really big, right? There's a big difference. So basically, one corner of the memory is like in the other corner is. So this basically, yeah, you can see that, right? So it's totally 2 different objects. This is the proof actually, 2 different objects. Okay. Um, so this is basically possible, and we call it reassignment. All right. So okay, so we did for the list, and then see that in list, yeah, it's possible, right? So that's a big contrast between the two. Okay, so let's go back. All right, so strings pretty much so list, strings, and tuples. We're gonna learn about a little bit of tuples today as well. um, Pretty much every ordered sequences in Python you can actually concatenate, right? Like it makes sense to combine 2 words into a phrase, right? It makes sense to add a paragraph to an already existing paragraph, right? So then we use the plus mark to add things in mathematics, right? So why not use the same symbol for this as well, because it's a similar operation, right? So we call it concatenation, and the symbol we use is actually the plus sign. Okay, and then because of that, because we are overriding something existing for math into this, we call that actually we overridden the plus symbol for strings or list as well. Okay, so that operation is in computing, it's called operator overloading. Okay, all right. So this let's do that for both list and strings, right? So for example, I have py. I have another one. Let's say code equals code, right? Like this. Okay, and then basically I can print py plus code, right? Right? It'll print Python code because we changed the name, right? So I'm going to reassign the name to this. Okay. All right. Python code. So similarly to with list as well. So if I check that list and list two is like this, um, like code, and then like for 23, right? I can print list one list plus sorry, this, let's say list two, something like list two. I'll get this, right? So this is the previous list, list. This is the list, and I am adding the content of this list. Okay. Notice the concatenation gives you added the content of the list to the one that before, right? So not entire list gonna go as a sub list. Okay. All right. So this content went to the end of this list. Okay. All right. So you can actually concatenate list, strings, tuples, all. So sometimes we call that operation is a common sequence operation. So concatenation is a common sequence operation. Okay. All right. All right. So the string concatenation. Let's go to the list. So remember, we actually list for list. We actually stopped right here, I think. Yeah. So right here, right? So these both string and list are uh, containers in Python, and they are classes as well, and also they are actually fundamental data types in Python. So let's take a look over here that what's available in the list class. Okay, so to see the operations available or attributes available in a class, we're gonna what do we use? Directory function, right? So we can basically say print dir. It's a built-in function, and we can simply put list or string. Okay, so we'll get this kind of thing, and in the end you can see towards the end you can see we have append here, clear, and then pop. So those are actually operations. Okay, so let's try to use some of these. Okay, so I'm gonna use this list. And by the way, guys, the concatenation returns uh, a new container. Okay, either new string if it is two lists, two strings we are concatenating. If they are lists, we'll get a new list. Okay, All right. So how do we check whether it's a new list or not? What can we do? Yeah, so we can check the ID and see that it's actually different. The new concatenated one should have a different one. Okay. All right. So so let's try um, this list. I'm gonna use this one and append. So let's try appending, right? So here's the basically append function. It doesn't return anything. Okay, it just internally modifies, so it work in place and add this new list or new item. Okay, so so let's take so a list, and then we gonna use append dot append, and then let's say so we're gonna append like code. Okay, and then we're gonna basically print this again. Okay, and you can see that the code is added to the end. Okay, so right here. Okay, all right. So can this be a list, another list? I think we can. Let's try it out. um Maybe not. So yeah, you can actually add it even entire list as well. It's gonna go as a one list. So this basically we call this a sub list. Okay, inside a list inside the list. Okay, all right. So what I'm gonna do this. All right. All right, and then basically let's try pop. All right, so print sorry list dot pop. There's some of frequently used operations, right? And then if we print it, okay, so and we'll see that the last item got popped out. Okay, and by default, if you do not put a pass an index as an input, it's actually going to pop out the last item. Okay, but if you want to pop out the first item, right, so basically you're gonna basically enter that index, let's say 0 here, and you will see that first item is gone now. Okay, all right. So try out other there are a bunch of other functions methods as well. We call them methods because they all belong to the list class. Okay, so as index function, given data value, it's actually written what index it's stored in, right? So it's really helpful one. You can count some like repeated like a count of something as well. um, you can make a copy of the list, and the insert, you can insert a value like insert opposite to addition sorry append, like pop, right? So you can insert a value, you can remove a value, you can reverse it, right? Sort, you can sort the list, right? So try out those things. Let's try the index, right? So let's say I want to find out where in my list 7 is stored, right? So basically print, right, a list, and then well, I'm gonna index, and I'm going to pass 7. That's the data point, the data value, sorry. So and then basically right, I'm gonna give me where which index it's gonna be. Oh, it's 7. Yeah, this is the list, right? So 0th index, index 1. Okay, all right. So likewise, so let's try, I think we can try sorting, so it will give you the sorted list. um, and then if you use count, and then basically it's gonna count how many of that item inside your list, right? The count of it. Okay. All right. So, like I said earlier, like the list are sequence type. Okay. So it's like the, I would say, like, it's a superset. So it's a sequence, and then sequences are strings, tuples, list, right? And a range is also, we're gonna learn in next module, module 10. Ranges are also sequences. Um, so you can use whatever you can pass your sequence into len function, and it's gonna return the length of it. You can concatenate two sequences. So here is the example, is a list, guys, right? And then if it is a numeric list, and then you can actually get the minimum of it. I think this has to be a numeric list. Yeah, all element must be of the same type. Okay, it's not just numeric, right? So it makes sense, right? If you have multiple types of things, and how do we get the minimum? So Python doesn't know the standard of calculating the minimum, right? So it has to be either characters, or all strings, or all numbers. Okay, same for max and sum as well. Okay, so it's only in the, basically list should be numbers only to get the sum. Okay, all right. And then the index will return the index of a value, and count will return the count of a value. Okay. All right, I think can go to the next one. Let's quickly do this one, guys. So you have to create a cost list. Basically, oh, oh yeah, yeah, sorry. Right, it's equals, right, this one, right? So basically you have to create a list name cost list to hold cost 1, cost 2, and cost 3, right? So we can actually do this, right? Right, so let's run it. All right, and then the values are coming in as 3 variables, and then just simply put them in a list. Okay, all right, it's 12, guys. Let's get our break. Okay, once you guys transfer to Berkeley, Suli is the one that you guys should apply. You might have more chances to get in that one too. So it's similar to CCI, but it's for, like, not just community college, all college students. Suli, so Suli has more comparison actually. Yeah. All right, guys, let's watch our video. So this one, guys, NBN, the guy talk about slicing in Python, which is out of focus of this class. But so we learn about list, right? So there's a list is flexible compared to strings, in the sense that we can actually change the values, like it's immutable, but it has consequences, right? So one consequence is called aliasing. Okay, so aliasing, what is aliasing? Basically, like giving a nickname kind of thing, right? It's an alias, right? For example, if I have another, like a kind of pet name that I also use for me, that's an alias for me, right? So that's the aliasing. So aliasing means, like, you create a name for yourself kind of thing, right? So this video we're gonna watch right now is basically going to show you a, a side effect of aliasing, or something, a consequence of bad consequence of aliasing, and then how to avoid it. So how to avoid part has the person talk about aliasing, sorry, slicing, right? So it's actually out of focus of this class, but it's good, it's a simple technique to learn. If you want, you guys are all ready for that as well. So I just published it right here in module 8. All right, so let's take a quick look on that, guys. Okay, so I'm going to create this list. Let's say this one. Okay, so it's a kind of reassignment now. Okay, and then I'm gonna create list 2 by assigning like this, right? So, right. So if you want to get the proof of, okay, these are same list, right? These are aliases. We print the ID value, right? So ID of each, right? So ID value, sorry, and then a list, right? And a list 2, ID of list 2. Okay, and we'll get the same value, right? So IDs are same. So it's the meaning of aliases. They are aliases, right? But if I now, let's say I change the list 2, and list 2, let's say the first item into like -1, right? And then I print the first list again, right? So I'm gonna only print the list, right? And you will see that it's actually, oh, I think I made a mistake, yeah, right? So remember, I didn't change the first one, right? I changed the second one, right? But I'm printing the list 1, and you see that it's also changed now. Okay, so the first list also changed. So these indicate both of them are pointing to the same list stored in the same location, right? Okay, so this sometimes can be an accident, right? Because you created this copy thinking that, okay, I'm going to copy this and change only this, but the original one also changed, right? So usually the consequences are undesirable. To avoid that, and then the guy showed you, you can actually use the cloning, okay, which is out of focus of this class. Okay, all right, all right. I think we can move on to this one. Okay, so I think one thing before, oh, we didn't actually go back. So let me go back to, so this is list. Did we finish this one? The strings? Oh, okay, let me check. This is still list strings. Okay. Talk about string concatenation. Yeah. So I want to show you one more thing actually. There's one thing, there are string operations are also available. So you basically print dir, nstr, right? Or you can simply put a empty string, and then it will actually print what's available operations from string class, right? And in the end you will have a bunch of them, right? So you can see you can capitalize, you can case fold. I don't know what it's about this center, probably the center element. You can count the count of a character, right? Encodes. There's a whole bunch of operations available, like it's digit, it's decimal, it means like it's it a digit or not, something like that, right? And it's alphanumeric. So a lot of boolean returning functions also, like checking for like it's all lowercase or not, right? Those stuff. And then you can join two strings. It's kind of similar to concatenation as well. You can make all lowercase, make all uppercase. There are a whole bunch of operations, right? So check them out and then try, like practicing them. Okay. I think the one that I'm going to use probably help you guys for today's assignment is this one. So let's use split. Okay. Um, right. So I'm going to use. So let's say um, str1 equals, all right, and I'm going to use split. Okay, print str1 dot split. Okay, and then we will see that it's actually returns a list of splitted list of words, right? So basically the you can see that I separated this each word with a space, right? So that's the default delimiter. Okay, so by default the delimiter for splitting is space. Okay, but if I use this, right, for example I use underscore, and if I actually now change the delimiter to underscore, right, like this, I'll still get the same list. So now I change the delimiter to saying that okay, use this as the delimiter for splitting. Okay, all right, but you can see that the split returns what type of thing? It's a list. Yeah, so basically if it is the default delimiter, then it's actually returns a list of words. So it's actually helpful, right? For example, you can get given a paragraph, you can get a list of words, and then if you get the length of it, you can get the number of word count as well, right? So there are benefits to that. Okay, so and one other thing I wanted to show you side by side along with list is this. Okay, so imagine, so we we tried that with list, right? Okay, so let me just confirm that. um yeah, so nope. Yeah, so what I'm going to do is I'm going to so we did it over here, right? Yeah, we saw that it's same id function, right? So we got that. Okay, so and then we saw the consequence. This is the aliasing, right? So let's try to, so can, my question is, can two strings be aliased as well? We can, right? So if str1 is, let's say, Python, right? So str2 is also Python. Sorry, um the same one. So what do I want to show here? Yeah, so 2 is str1. Okay, all right. Well, no. So let me start with this one. I'm going to start this. Okay, all right. I'm going to, so not alias, I'm going to try a different list. Let's say list2 equals the same. Okay, all right. So will the IDs be different or same? Print. What do you think? All right, list2, id of list2. Different, right? They're different. So well, the same content, right? So let's do the same for strings. Okay. All right. Will they be different as well? Well, following the same pattern, logically true, right? Should be, right? So, but you will see that it's actually not. Okay. So this is same. My question is why? Oh, is I mean, this is by design from Python, so this is a design choice. So and also remember, it's not for all strings, short strings. And then the guy actually from earlier class actually found out it's actually the, I think length was 11. If the string's length is less than 11, Python do this. If if it is more than that, Python don't do that. So you can actually try out right now. Okay. So let's stick with this one some already. So it's, you can see that they are basically aliases, right? Pretty much. But it's not, I'm not making str1 equal str2. So not aliasing action. I am basically recreating Python again, same Python, right? So to a different variable. For list, right? They're going to be two separate lists, even though the content are same, right? So, but for short strings, we'll see why later. It appears like it's same. So this is a optimization strategy. Here's why, right? Imagine I'm creating 1,000. I'm having to create 1,000 variables, but same with Python. Don't ask me the use case, but hypothetically think, right? Like maybe you in a loop you do that, right? So um, so now each one same content, but all 1,000 in separately stored in the memory, right? And that's a waste of memory, right? Why? Because strings are immutable, right? You cannot do the item assignment, you cannot change once created strings. So why not enabling this, right? So that no one can now change. So you still have basically you save memory, right? You save memory by doing this. So just one this guy in single location of memory, and you basically point into the same location, right? See that the IDs are same, right? That means it's just a address, right? So rather than 1,000 copies, you have one single copy and all 1,000 variables is pointing to that, right? So um, so this is basically it's going to save memory, right? So it's safe because unlike list, we don't have this problem with strings because strings are immutable. So it's also safe as well. So and that's why. Okay. So I want to show you this one. So let's take out the longer strings. Okay. So I'm gonna reassign. Who was that? Right. I'm going to reassign. So this one, like this Python coding. Looks identical, right? So let's check out the thing. You can see that there's difference, right? So they are different. So you can investigate this one by just googling as well. I think the characters difference will probably around 11, and I also depend on the version as well. and then they may have earlier low version may have a different strategy as well. Okay, but the reason why is basically it's a optimization strategy. Okay, all right. So, but anyway, both of these are immutable. There's nothing wrong. Nothing. It has nothing to do with immutability in the sense of the size, right? But for short strings like this, Python use the same. So basically, like this, like single copy thing. Okay. All right. Questions? All right. I think we covered that. So let's quickly go on to. We did that list basics. All right, so let's learn about tuples. Okay, so it's mentioned over here, tuple, and sets and dictionaries. Will maybe we'll finish this module on Thursday. Um, okay, so let's talk about tuples. Okay, all right. So tuple is actually very similar to list. Okay, it's like it can have it's a heterogeneous data structure. That means you can have variety of types in a single tuple as well. So so we use actually small brackets, not square brackets. Okay, for a tuple. Okay, so this is how you define a tuple. You can also omit the bracket, which is still a tuple. Okay, this also works. Okay, so for example, print type and a tuple, right? All right. So it's a tuple. Okay. So if you put another one like with the same content, but now inside brackets. Okay. And pretty much this one also tuple. Okay. But it's good to put um, the brackets, guys. Okay. All right. So what's the difference between tuple and list then? They are very similar to list. But what's the difference? What is the difference? So let's try. Okay, let's try this. So a tuple, I'm going to change the zeroth element to something like um, a -1 again. All right. So if I try to do that, that's not possible. So tuples are immutable. So very similar to list, but unlike list, they are immutable. So that means all those list operations that were mutations, like changing values inside, are not possible with tuples. So you will not see append, you will not see pop with tuples. Okay. So so basically the tuples are immutable. So this is not possible. Okay. Right. So right. So if you want to see the tuples, like you can print dir, um, like a you can do this. Okay. So you can see that there's no, like there's only count and index, which are the two non-mutation operations. Okay, you can count something that inside, or you can get the given the value, you can find out what is the index. So rest of the all that we saw in the list class are all mutations. So they are all mutation operations. Okay, so they are changing the existing list. Okay, so those are the available tuple operations. Okay, all right. So what's the advantage of using tuple then with this context only? Anyone? Yes. Yeah, you don't have to worry about aliasing. That's an advantage. And yes, with that one specific place we can actually use a tuple. This is a little bit hard to imagine though. Imagine, so we have been using function for a long time, right? Imagine I have more than one thing to return from a function. I can now return it as a tuple, right? So you can simply put them in a comma separated tuple and you can return it. It's safe because no one can change it, right? So you can also return a list from a function, but it's prone to aliasing, right? But you can actually return that many things that you want to return from a function. Usually it's a couple of things, not many, right? And then you can actually return it as a tuple, which we're gonna do it today actually. Okay, all right. So with that, I'm going to actually go to today's problem, which is this one right here, street address. Okay, all right, guys. I just published it. It's in module 8. Okay, so this one is really practical problem. This really have applications. Where do we have this application? Given address, finding the zip code and the house number, which who's going to use it in real world? Post office, right? And in fact that's what they actually do, right? Yeah, so basically this, right? So we send mail, right? So the mail goes like this. They actually take a picture of all the address side of the mail, right? And then from that picture they use optical character recognition to convert the image to text. So now you have the text address like that one, right? The string. So then they use a solution that we're gonna write today, something exactly similar to capture the zip code and house number. So once you capture the zip code, it's a big machine, right? There are bins. So mail goes to all of each and every zip code, and then basically from that zip code, mailman get that bunch of, and basically there's another I think there are another bunch of sorting based on the house number and the street address, right? And then mailman get that and deliver. But there's a manual intervention. Usually, when the optical character recognition algorithm, if it can't characterize it properly, all those mail goes to a single bin, and that's where a human actually reads the label and try to figure out where is the zip code and other things. Okay, so yeah, so this one has real applications. We're gonna basically do it in a simple way. Okay, all right, that's what we are going to do today.